All right, class, welcome to part 2 of lecture 13. So what I've learned from this setup is that the audio is really bad unless I speak very loudly the whole time. So hopefully this time I can remember to speak loudly the entire time. There are lots of parts where I don't know what I was saying in the other video because the audio didn't pick it up very well. That's probably because I was mumbling to myself. Where normally you would be able to hear that with my microphone, now you cannot. Okay, so I apologize for that. Here is part 2. So it's just going to be more examples, but we're going to sort of go backwards. So here is the idea. Since z-scores correspond using this calculator to probabilities, typically to the left of the z-score, this means that we can sort of go backwards. So we can answer questions where we go backwards. Okay, so let's try to do some examples like that. We'll use the same setup, that way we don't have to start up a whole new problem. So let's do something like this. Find the height. So instead of finding the probability, we are finding the height of a 3-year-old that is taller than 20% of 3-year-olds. So this is the opposite of what we did before. Before, we knew the height, we're given the height, and you would want to find the percentage that that height is above or something like that. Whereas now I'm really trying to find the height and I'm given a percentage. Okay, so let's do this by trying to make it sort of methodical. And the first thing we're going to do is we're going to reframe the question. So what we're really doing is we're finding the value or the data point, little x, that's the height, where 20% of the area is above that height. Wait, sorry, you want to be taller than 20%, that means you want it below. So we want to find the value of x, find the height, such that 20% of the area is below it. Specifically below that corresponding z-score. Okay, so we're still going to draw the situation for step 1, just to sort of help us visualize what's going on. So now the idea is something like this. I still have that same exact normal probability distribution with 38.72 in the middle. And now what I know is, I don't know what this is right here. This is my little x that I'm searching for. It's a specific height. But instead what I know is that 20% of the people are less tall than that, aka this red area is 0.20. So the probability of being below this mystery data point that I don't know is 20% or 0.20. This is what we're trying to find. So now we're just going to use z-scores to do this. So since z-scores correspond to probabilities below it, we can use that same calculator that I have linked on Moodle But instead of typing in the z-score, because we don't know that, we're typing in the cumulative probability, the probability to the left. So if you do that, you type in 0.20 for probability, that'll tell you what will pop up for the z-score is z equals negative 0.84. And I'm rounding, depending on the calculator you use, it'll round in various ways, but this is what I'm using. Okay, so this is the z-score corresponding to this area. So that means that what I'm really doing is I'm having this other probability distribution, and I've found that negative 0.84 is this z-score that has area equal to 0.20 on the left. So now I got to turn that z-score back into a height. So that's the next step. Okay, and that step's not so bad. Just a little bit of algebra. So now we're going to solve for little x that corresponds to this z-score. So I'm going to use my z-score formula, z equals x minus the mean over the standard deviation. But now I still know the mean and the standard deviation, that hasn't changed, but, sorry, it's 38.72. But now, instead of knowing x like I did in the previous problems, I know the z-score. And I'm finding the x instead of vice versa. So I can solve this equation by multiplying 3.17 up and over. And then I can add the 38.72 over. And if you do all this work, you'll end up with 36.1. So you can use a calculator to help you with those things, but that's what you're going to get. So then finally, the last step is, of course, context. Answering the question in actual context. So what does this 36.1 represent? Well, it's the answer to our question. So the height of a 3-year-old that's taller than 20% of the other 3-year-olds is this height, 36.1. Okay, so that's it. Hopefully not so bad. All right, so now let's move on to, let's use a different probability distribution. But it all works the same. It's just, the only thing that changes is different context. Okay, so here's a very common thing that people look at. It's SAT scores. So scores on the math SAT are normally distributed. So I'm able to draw this bell curve, and it has a mean attached to it and a standard deviation attached to it, just like always. That's not going to change. But what we want to find out often changes. So this time we want to find out what scores separate the middle 90% from the top and bottom 5%. So this is a question that's very similar to the one we just did. It's the backwards way. It's not like the ones we did in the first part of the lecture. It's much more like the one we just did. Because now I'm finding, again, the scores. I'm not finding a probability or a percentage. I already have that, except it's written in a sort of more complicated way. But once again, the best way to go about this is to sort of draw the situation to help us visualize what's going on. So let's do that. So let's draw the situation. What's going on is we have this bell curve with the mean as 510 and the standard deviation is 116. So that's going to tell us these two inflection points. If I add 116, what is that? 626. And I can't subtract in my head, so let's write this. That's that one. Okay. But what we're looking for is we want to know the two scores that separate the middle 90%. So this area should be 90.9 from the top and bottom 5%. So this is going to be 0.05, and then this is also going to be 0.05. So we're trying to find, what are we trying to find in this picture? We're trying to find these two little x's. What are these actual scores that create this situation? That's what we're trying to do. Okay, so before we can get to that, we want the z-scores for the same picture. And then we'll turn those z-scores, just like we did before, into the actual relevant context. So we want the z-scores first for the same picture as the idea. Okay, that one's too quick. So again, the idea is that when you're dealing with z-scores, you're in this situation, but now I'm trying to figure out what are these two z-scores that separate the middle 90 from the top and bottom 5%. Okay, so what I can do using that online calculator is I can know that this is 0.05 area, 0.05 probability, to the left of this z-score. So if I use that online calculator, I can look up the z-score for probability of 0.05. If I type 0.05 into the probability, it'll tell me the z-score where the probability to the left of that z-score is 0.05, but that's exactly what this situation is right there. So if I type that in, it'll be -1.645. That's the z-score you'll get. Now, because I'm looking for two z-scores, I'm going to call this one z1 and the other one z2. So I'll call this one z1 because it's the first one I found. And then you could look up, so for the other one, how much probability is there to the left of this one? Well, it's 0.9, there, but then another 0.05, it's so it's total of 0.95. So I'm going to look up the probability. I'm going to look at the z-score for probability to the left being 0.95. And if you do that, you'll end up, so my second z-score, z2, will end up, well, it's actually going to be the same number except positive. And we could have guessed that by using symmetry ahead of time anyway, because the bell curve is symmetric, which means that if this z-score has 5% to the left, then on the other side, the same z-score but positive should have 5% to the right. And that is what happens. So you could also use symmetry instead of looking this one up. But either way is fine. So the point is I now have my two z-scores. Z1 and Z2. So now I got to turn them into the context of the problem, which is SAT scores. So I got to turn these two Z-scores into X1 and X2 here, using the same method I did last time. So let's do that. Solve for the X1, X2 corresponding to these two Z-scores we just got. So for Z1, I'm still using the same exact Z-score formula, but now my mean is 516 and my standard deviation is 116 for this context of this problem. And if I solve this equation by multiplying 116 over and then adding 516, I'll get 325. And then if I want to get X2, the other score corresponding to this Z-score, Z2, 1.645, exact thing. Oops. Oops. So now I do the same exact thing. And I'll end up with, if I solve this guy, I'll end up with 707. My PC is about to die. Sorry, let me just. Okay. So those are my two SAT scores corresponding to the two Z-scores, and I have a probability of 0.9 in between them, aka an area of 0.9, aka a 90% in the middle. So now, in context, we can finally finish the problem. So the two scores, 325 and 707, separate. They do the thing the question wants us to do. They separate the middle 90% from the top and bottom 5%. Okay, so that is it for this lecture. Hopefully the audio came out better this time. See you next time.